In 12.2, we're going to talk about arithmetic sequences. And all an arithmetic sequence is something like this. So we have 4, 9, 14, 19, 24. And to get from one number to the next, all we did was add 5 each time. So an arithmetic sequence is just like arithmetic. You have to add a number to get to the next number each time. When you identify it like this, you can use this simple formula, a sub n equals a1 plus n minus 1 times d, to solve for the rule of how they got this arithmetic sequence. So in the example above, a sub n equals a1, which is the first term, which is 4, plus n minus 1, we don't change that, times d, that's the difference, which is adding 5, so times 5. This is the rule for the above arithmetic sequence. The other thing from this section we need to talk about is, in order to write a rule, if you're given 2 terms. So it says when n is equal to 8, a is equal to 21. The term or range is 21. When n is equal to 27, the term or range is 97. So we need to come up with a rule based on these 2 very small pieces of information. But what we're going to do is take these and plug them back into that formula we know from before, and then we're going to solve the system of equations. So the formula is, to remind you, it's a sub n equals a1 plus n minus 1 times d. And we're going to do this for both of them. So for the first one, a sub n is equal to 21, because that's the range. We don't know what the initial term is yet, but we know when n is 8, a sub n is equal to 21, so we'll plug that in. And for the second one, we know that it's equal to 97 when n is equal to 27. So we'll just clean that up a little bit. 21 equals a1 plus 7 times d, and 97 equals a1 plus 26 times d. Now we need to solve that system of equations. So we're just going to subtract the 2 to get rid of a1. We just subtract them. So 21 minus 97 is going to give us negative 76. a1 minus a1 is nothing. And 7d minus 26d is negative 19d. So d is equal to 4, positive 4. Now that we know that d is equal to positive 4, we can plug that into one of these equations. It doesn't matter which one. We're just going to plug it back in. So 97, I'm going to run out of space here, so I'm going to go ahead and erase a little bit, maybe up here. But I'll change colors so you know I'm working ahead. So we have 97 equals a1 plus 26 times 4. And when we do that, we solve for a1 equals negative 7. Now, we pretty much know everything about this equation now. We know a1 and we know d. So now we can just go ahead and plug in the information. We have a sub n equals negative 7. Just plug it into the original equation, plus it's n minus 1 times 4. And we were able to do that because solving the system of equations, we were able to find what d was, and what A1 was, which is all you need to write an arithmetic sequence. Now the book might have you simplify it. So to simplify it, you just multiply this out. So negative 7 plus 4n minus 4 equals negative 11 plus 4n. So a sub n, the rule for this sequence is a sub n equals negative 11 plus 4n, or if the book doesn't have you simplify it, you can just leave it like that. Is finding the sum of a finite arithmetic series. In the last section, we talked about how to find the sum of any type of series, but in this section, if you have an arithmetic series, you can make it go a lot faster as long as you know it's arithmetic series. So take, for example, this one. So we have 12 on the top and I equals 6 on the bottom. I'm really bad at drawing sigma, by the way. Negative 5i plus 17. So what this says is find the sum of this series starting at I equals 6 and going up to 12 of this equation, negative 5i plus 17. So, I mean, we could do this 7 times, right? We could plug in I equals 6 and then plug in I equals 7, I equals 8, I equals 9, I equals 10, 11, 12, and then add those together. But we can use this equation to skip a lot of steps here because we know it's arithmetic series, so the equation works. So in order to do this, we need to find what A1 is, and we need to find what AN is. A1 is the first term, and AN is the last term. So the first term and the last term. And then N is the number of terms. Okay, so first we'll find A1. In this case, it's the first term, so it's whatever it equals when I equals 6. So negative 5 times 6 is negative 30, plus 17, we have negative 13 for A1. We need AN, so in this case, AN is A12, the last term. And that is what happens when it equals 12. So negative 5 times 12, negative 60 plus 17, negative 43. Now we can set it into the equation. The sum of these terms is equal to n, the number of terms. So how many terms are there between 6 and 12? Well, there's 6, 7, 8, 9, 10, 11, 12. I counted on my fingers. That's 7 terms. That's 7 things. From 6 to 12 is 7. 6, 7, 8, 9, 10, 11, 12. Times negative 13 plus negative 43 divided by 2. Negative 13 plus negative 43 is negative 56. So 7 times negative 56 over 2, it comes up to negative 196. So the sum of this series is negative 196.